All right, let's talk about AI. For years, the story has been all about bigger is better, right? We hear about these giant models with billions and billions of parameters. But what if the real future of AI is actually smaller? Today, we're diving into the incredible world of small language models, and I'm going to show you why these little powerhouses are about to change pretty much everything.
And look, don't just take my word for it. Let's kick things off with a huge prediction from the research firm Gartner. They're saying that by 2027, companies will be using small, specialized AI models 3 times more than the giant general-purpose ones we always hear about. I mean, just let that sink in. That isn't just a minor trend. That's a revolution in the making.
And it's not just the market analysts either. NVIDIA, the company that's literally building the hardware for this whole AI boom, they're all in on this too. They are flat out calling small language models, or SLMs, the future of AI agents. So when the company making the engines of the revolution tells you to look at small, you know something really big is happening.
Okay, so with all this hype, you're probably asking the big question. What is a small language model anyway? Let's introduce the star of today's show. I want you to think about it like a boxing match. In one corner, you've got the heavyweight champion of the world, the large language model, or LLM. It's huge, it's powerful, it can kind of do a little bit of everything. But then, in the other corner, you have our challenger, the small language model. It's way leaner, way faster, and it's been training for one specific fight.
So here's the deal. An SLM is still a super smart neural network, but it's built with fewer muscles, or parameters as they're called. It's not trying to do everything at once. It can't write you a Shakespearean sonnet and debug your Python code. Instead, it gives up that broad skill set to become an absolute master of one thing. And because of that, it's incredibly fast and uses just a tiny fraction of the memory.
So how do you even make one of these specialized little brains? Well, you don't always have to build them from the ground up. A lot of the time, the best way is to take one of those big, powerful models and put it through, like, a training montage to make it smaller, quicker, and way more focused.
This whole transformation process really boils down to 3 core techniques. And they've got some pretty cool names too: quantization, pruning, and distillation. So let's break down what each of these actually means.
First on the list, we have quantization.
Now, this might sound complicated, but the idea is actually super simple. It's all about making the model's internal math a little less precise, but way more efficient. So, instead of using these really long, complex 32-bit numbers for all its calculations, it learns to use smaller, simpler 8-bit numbers. And the result? The model gets way smaller and faster, but, and this is the magic part, it does it without really losing any accuracy for the one job it's supposed to do.
All right, next up is pruning.
And honestly, the name says it all. You know how a gardener will snip away useless branches to help a plant focus its energy and grow stronger? Well, that's exactly what AI engineers do to a neural network.
They basically go inside the fully trained model and look for all the little connections, the neurons and parameters that aren't really contributing much to the final answer. And then they just snip them away. It's literally trimming the fat, and it makes the model so much leaner and more efficient, all while keeping its core knowledge perfectly intact.
And finally, we get to my personal favorite. It's a really cool process called distillation.
I want you to think of this one like a mentorship program. You've got this massive, supervised teacher model on one side and a small, empty student model on the other. The teacher gets fed a ton of information, and the student's only job is to watch the teacher and learn to copy its answers perfectly. Over time, the student distills all of that essential wisdom from the giant teacher, packing it into its own tiny, hyper-efficient brain. It's pretty cool, right? Okay, so now that we know how these little guys are made, let's head back to our boxing ring for the tail of the tape. How do SLMs and LLMs really stack up against each other, head to head? And really, this table tells the whole story. SLMs are working with parameters in the millions, not billions. And that simple fact changes everything. It means they need barely any memory to run. It means they can give you an answer almost instantly. We're talking fast enough to run right there on your phone. LLMs, on the other hand, are so big they're pretty much stuck in the cloud. And maybe the biggest kicker of all, the cost. Building and running an SLM is just so much more affordable. It's not even in the same league.
But here's the plot twist. We've been talking about this like it's a competition, but the reality is way more interesting. It's not always about the small model replacing the big one. Sometimes it's about having them work together as a team.
Check this out. This is a brilliant setup called a pipeline. When a request comes in, it first goes to a super fast, super cheap SLM.
That little model handles all the easy stuff. Maybe it filters the request or writes a quick first draft. And only if the job is too complicated does it get passed up the chain to the big, expensive LLM. What you get is a system that saves time, saves energy, and, most importantly, saves a ton of money.
So, let's get to the bottom line here. We know what they are, we know how they work, so where are these small models actually making a big impact out in the real world?
Well, there are 3 areas where SLMs are just total game changers. Number 1, privacy. Because they can run right on your phone or your computer, your sensitive data never has to leave your device. Number 2, high-volume, low-cost tasks. Think about processing millions of receipts or customer service emails. You don't need a genius model for that. You need a cheap, fast one. And third, hyper-specialization. It's so much easier and cheaper to train a small model to be a world-class expert on one very specific thing, like your company's private code base.
And believe me, this isn't just a theory. The biggest players in the game are already doing this. Companies like Uber and even OpenAI, the people who make the giant GPT models, are actively using SLMs to make their own systems smarter and more efficient.
Okay, take a look at this system diagram from Uber. Now, I know it looks super complicated, but the main idea is actually really simple. See all those different boxes? They're using a bunch of different small, specialized models along their data pipeline to do the quick, efficient work first. This is that teamwork, that collaboration we were just talking about, happening at a massive scale in the real world.
So let's just wrap this all up. What are the big things to remember? First, small language models are the fast, efficient, and affordable specialists in the AI universe. Second, that makes them the perfect tool for very specific jobs, especially where privacy, speed, and cost are a big deal. And third, they can work by themselves or as part of a team with bigger models, which makes them incredibly flexible. The bottom line is, the rise of SLMs isn't just a small update, it is absolutely one of the most important trends shaping the future of AI right now.
Which really just leaves us with one last question to think about. As these powerful AI brains get small enough to live on our phones, in our cars, everywhere, what's that one everyday task you wish you had a tiny, specialized AI expert just handle for you? The possibilities are really starting to feel endless. Thanks for watching.